Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on the 20th of June, 2025 T, 19 hours, 38 minutes, and 34 seconds, .0000Z. This paper, published about 10 days ago, introduces a new visual editing framework that users preferred over existing methods in over 93% of cases for complex tasks. The paper is titled BlenderFusion, 3D Grounded Visual Editing and Generative Compositing, and as we'll see, the visual results really back up those numbers. The core idea is to solve a big problem in generative AI, the lack of precise, 3D aware control when you want to edit multiple things in a scene. Alright, to really frame their contribution, this table provides a direct capability comparison. It shows how BlenderFusion stacks up against other methods, like Object 3DIT and Neural Assets. The columns show different controls for visual elements like the object, camera, and background, and for specific object actions like multi-object editing or even non-rigid transforms. A non-rigid transform just means deforming an object, like bending it. As you can see, BlenderFusion is the only method here that gets a green checkmark in every single category, demonstrating its comprehensive control. Building on that, this next figure really unpacks the how. It shows the full BlenderFusion pipeline in 3 stages. First is layering, where foundation models analyze the source image to create 3D object meshes. Think of it like digitally cutting out the objects and understanding their shape. Next is editing, where these 3D objects are moved, changed, or replaced inside Blender. Finally, generative compositing. This uses a special dual-stream diffusion model. A diffusion model is a generative AI that creates images, and the dual-stream part means it looks at both the original and edited scenes to blend everything together into a final, photorealistic image. Moving to the results, this table provides the hard numbers. It compares BlenderFusion against other models on several datasets, using metrics at both the object and full-frame level. You'll see things like the Fréchet inception distance, or FID, which is a popular score for judging image realism, where a lower number is better. And looking at the data, BlenderFusion consistently comes out on top. For instance, its Fréchet inception distance score on the MoviE dataset is just 9.11, while the others are over 15. This pattern holds across all metrics, providing strong quantitative proof. And those numbers really come to life when you look at these qualitative comparisons. This figure shows side-by-side results for tasks like moving, rotating, and scaling objects. The goal is what's called disentangled control, which just means you can change one element, like an object's position, without messing up the camera view or the object's identity. And you can see it clearly. While other methods distort the objects or the background, BlenderFusion's edits are clean and consistent. Look at the rotated chair, for instance. It's the only one that maintains its proper shape. And the power of this framework becomes even more apparent when we look at these more complex multi-object scenes. This figure shows a series of fine-grained edits, which just means very specific and detailed changes. You can see the input image, the intended edit shown as colored blocks, and then the results from a competitor versus BlenderFusion. Just look at the examples, whether it's rearranging mugs on a table or even shifting cars on a busy street. BlenderFusion's results are consistently sharper, more realistic, and correctly placed, avoiding the artifacts and blurriness seen elsewhere. So, what's the secret sauce that makes BlenderFusion so effective? Well, this figure breaks it down. It's what's called an ablation study, which is a way of testing a model by adding its special features one by one. Moving from left to right, we see the results get progressively better with each addition. The key improvements come from 2 special training strategies. First, source masking, which helps the model cleanly remove an object or change the background. And second, simulated object jittering, which helps it learn to move an object without changing the camera view. So, putting it all together, what we've seen is that BlenderFusion represents a major step forward for visual editing. The key takeaway is how it successfully merges the world of 3D graphics with generative AI. By using Blender for editing, it gives creators precise, 3D-aware control over individual objects and the camera, something that's been a real challenge. The result is the ability to make complex, fine-grained edits that are far more realistic and consistent than previous methods. That's all for this edition of AI Research Roundup. Thanks for tuning in.